we'll start the first theorem of the triangles chapter, that is BP theorem. BP theorem means basic proportionality theorem, and it is also called as the Thales theorem. It is very important theorem in the triangles chapter. To know the basic proportionality theorem, let us draw a triangle here. For this triangle, if a line is drawn parallel to one side of the triangle, it intersects other two sides at the distinct point, and also it divides the other two sides in the same ratio. Means A, this is D, this is E, means AD divided by DB is equals to AE divided by EC. Yes, we need to prove that this AD divided by DB equals to AE divided by EC. For that, let us write a data construction to prove and proof. First, that is data. Here data means we'll write the given data first, given conditions first. Here in triangle ABC, they have given a line which is parallel to BC. That line DE is parallel to BC here. Right? Now to prove, what will do? To prove, we need to prove that this AD divided by DB is equals to AE divided by EC. Right? Then construction. To prove this condition, we have to make here some construction. Right? We'll draw a perpendicular line from the point D to AC. I will name it as N. And one more perpendicular line from the point E to a AB line, and it is named as M. And we'll join BE and DC. Right? We'll write it here. First, we'll prove this left hand condition. For that, I will consider a triangle ADE. Yes, the height of this triangle is ME. Right? The height of this triangle is ME. Then again I will consider one more triangle DBE. The height of this triangle DB is again EM, because a triangle EDM, it is an obtuse angle triangle. So the height of this triangle lies outside here. We can observe it here. The triangle DBE is an obtuse angle, so the height of the triangle, obtuse angle triangle, it lies outside. And even ADE is a triangle. It is a triangle whose height lies here inside the triangle, that is EM. We'll write it. We'll use here area of a triangle formula to find this condition. Area of a triangle ADE is equals to half into, here for the triangle ADE, base is AD and height is EM. And again second triangle is DBE. Triangle DBE is equals to again half into, base is DB into height is EM. Right? Now we'll take the ratio of these two areas. Area of ADE divided by area of ADE is equals to half into AD into EM divided by half into DB into EN. Now half of get cancels, EM, this is M, right? EM get cancels. Then the remaining part is area of a triangle ADE divided by area of a triangle, this is DBE, area of a triangle DBE is equals to AD divided by DB. We can observe here we got the left hand side. We can observe it here. We got the left hand side. Now to prove right hand side, here we take again triangle ADE and a triangle DEC. Here we'll take ADE triangle and one more triangle DCE, right? These two triangles we'll consider. For this triangle, again the height lies inside the triangle. For the triangle ADE, height lies inside the triangle. Again for the triangle DCE, it is an obtuse angle. So the height of this triangle lies outside the triangle, right? We'll write this condition here. So area of a triangle ADE is equals to half into base is AE into height is DN. And again area of a triangle DEC is equals to half into base is EC and height is DN. Again we'll take the ratio of these two equations. We'll get area of a triangle ADE divided by area of a triangle DEC is equals to half into AE into DN. That is divided by half into EC into DN, right? Half get cancels, DN get cancels. Remaining part is area of a triangle ADE divided by area of a triangle DEC is equals to AE divided by EC. You can see here we got the left hand side, right? Now we call this as equation 1 and this as equation 2. Now we have to show that equation 1 equals to equation 2. Then only we'll get this equation. To show that equation, here one more concept will get arises. That is, we can see that triangle EDB and the triangle DEC lie on the common base and they lie between the two parallel lines. Therefore, the area of a triangle DEB and the area of a triangle DEC are equal. We'll use that concept. We'll write here triangle EDB and a triangle DEC are on the same base. They are on the same base, what? DE. And between two parallel lines, between two parallel lines, or between two parallels, we'll write between two parallels DE and BC. So area of a triangle EDB is equals to area of a triangle DEC. We'll call this as equation 3. Here I will replace this DBE, this DBE by DEC from equation 1. So now equation 1 becomes area of a triangle ADE divided by, I have told I will replace this value by this now. So area of a triangle DEC is equals to AD divided by DC. We'll call this as equation 4. Now we'll compare equation 2 and 4. You can observe that left hand side are equal. So right hand side both are equal here. We'll write here statement comparing equation 2 and 4, we get AE divided by EC is equals to AD divided by DC, or AD divided by DC is equals to AE divided by EC. This is what the BPT theorem states. This completes the BPT theorem proof.